So today we're going to talk about lipids and proteins. Okay. Anybody know anything about lipids and proteins?
Lipids are fats.
Lipids can be fats. They don't have to be fats, but they can be fats. Fats are what we think of when we think of lipids a lot, right? And proteins we think of when we think of protein.
Amino acids.
How about red meat? That's what I think of when I think of protein, right? Big old fat steak. That's protein, right? Okay, we're going to talk about what makes them what they are, okay? So we're going to start by talking about lipids, chapter 15. And note, we're going to cover sections. We're not going to cover everything in there. So when you do the homework, who's already done the homework? I had somebody in the other class tell me they'd already done the homework.
I did
Right.
what I could. I mean, there's some there that.
There's some there that you might get the answer to today, right? But other ones, there's not like any calculations and it's not a whole lot of detail. There's no drawing, maybe one. But other than that, I mean, there's none from 15 to 16. There's no drawing from 15 to 16. Okay? So, lipids are a type of biomolecule, right? That your body has, that all living organisms have. Okay? They can either have a fatty acid tail or a steroid nucleus. Okay? And we're going to talk about fatty acids and steroids. Lipids are not soluble in water. Anybody know that? You already know that? How'd you know that?
They have a hydrophobic.
They're hydrophobic, and you ever tried to mix any lipid with water? You ever see vegetable oil in water? Doesn't mix, does it? Okay, not soluble. So, lipids can be broken into two classes, fatty acids and steroids. And we're going to spend most of our time talking about fatty acids, not steroids. Okay? Fatty acids are waxes, fats, oils, and phospholipids. They're all esters, and they can be hydrolyzed, just like we did before when we did acid hydrolysis and base hydrolysis. And there are some other molecules. Steroids contain that central molecule down there, and they're characterized by those four rings. We're going to talk about those four rings. So, you can further break down fatty acids into these four categories: waxes, triacylglycerols, glycerophospholipids, and sphingolipids. So, lipids are characterized by the presence of fatty acids or a steroid nucleus. Which type is described here? Has a four-membered ring system. Fatty acid or steroid? Steroid, right? Contains long carbon chains. Fatty acids. Includes carbonyl groups.
Fatty acid.
Are fatty acids. Ooh, and I can't go back. Yeah, they're fatty acids. Carbonyl group is what? Anybody know what carbonyl group is? C double bond O, right? That is found in a fatty acid. And we'll show why. It actually also, fatty acids often contain carboxylic acid as well. That's why they're called fatty acids. Okay? Which is not a characteristic of lipids. May contain a carboxylic acid group. I just said fatty acids are called fatty acids because they have carboxylic acid. So they do. May contain a four-ring structure.
Yeah.
Is that a lipid? Yes, that's a steroid, right? Soluble in water?
Yeah.
No. Fats and steroids are not water soluble. Mostly nonpolar. Yeah, that's fats, right? Okay. Fatty acids. Let's talk about the structure of fatty acids. Saturated fats are like chips that stack together. Those look like what kind of chips? Pringles, right? Pringles stack nicely together, don't they?
Yes.
These guys down here at the bottom are like
Potato chips.
kettle chips, right? You can't say Lay's because Lay's crumble up too easy. But kettle chips are a little bit rigid, but they don't stack together at all, do they? They're just a big ball, right? Why is that? Well, think about the words there. Saturated and unsaturated. Anybody remember what those words mean?
Whether or not they have full hydrogen capacity.
Whether or not they have full hydrogens. What's another way of saying that? If you don't have full hydrogens, what do you have?
Unstable.
Not unstable, because it can be stable, but what do you have instead of hydrogens? You have You remember? Instead of hydrogens, what did you replace the hydrogens with? Because you don't have the maximum number of hydrogens. Double bonds? Okay. Unsaturated fats have double bonds in them. Okay? Saturated don't have double bonds. They contain the maximum number of hydrogens. Okay? We're going to talk about the differences. And this really controls the difference in these two types of fatty acids. So, all fatty acids are long, unbranched carbon chains with carboxylic groups at the carboxylic acid at one end. They are not soluble in water. Saturated fatty acids do not contain carbon-carbon double bonds. Unsaturated contain at least one double bond. Okay? So the difference is maximal versus non-maximal number of hydrogens. So unsaturated means has some double bonds in it. And we're going to talk about why that makes a difference. Here is an unsaturated fatty acid. This is, which one is this? Lauric acid. Okay? Note it has a long chain of, there's actually 12 carbons in that chain. And then the carbon on the end down there is a carboxylic acid. You should recognize that as carboxylic acid. It's carbonyl carbon that also has a hydroxyl group. Okay?
Which one is it on?
The one all the way on the far end, right? It's a carbonyl carbon that also has OH on it. That makes it a carboxylic acid, right? Now this is a saturated fatty acid. Okay, it's lauric acid. Here's some other types of saturated fatty acids, palmitic acid and stearic acid. Here are a couple of mono unsaturated. What do you think that word mono means? It means one. So this is unsaturated one time. It has one double bond in the fatty acid tail. Okay? Palmitoleic acid found in butter, and oleic acid is found in olives and pecans, and grape seeds. Okay? They both have one double bond. Polyunsaturated fatty acids have many double bonds, like linoleic acid, linolenic acid, and arachidonic acid. They all have multiple double bonds, at least two, right? Some have way more than that. So, what's the difference in between unsaturated and saturated? That's what we're working up to. Well, when you have an unsaturated fatty acid, you can either have a cis or a trans form, right? Remember from when we did cis and trans isomers a couple weeks ago, right? Now look, if you have the cis form, look at this. Think about the trans form, you might as well have fully saturated, because let's say my arm is the fatty acid. Well, when I bring another fatty acid together, they fit together like this, right? They all fit together and they can line up. And they're attracted to each other somewhat because they're big. But when they're like this, they're kind of like potato chips laying randomly in a bag. You have to do a lot of, if you were to take those lays out and try to stack them up, could you stack them?
Probably eventually.
It would take a lot of work to stack them, wouldn't it? They'd have to line up just right. But the other ones, Pringles, they stack up nicely without doing a whole lot of work, don't they?
You just tip it over.
Yeah, it's all good, right? So see the difference now? When you put those cis fatty, unsaturated fatty acids, this is what they look like. So this leads to the difference in the properties. If you either have trans fatty acids or you're saturated, you fit together. Therefore, you're probably a solid at room temperature. But if you have cis double bonds, you're probably going to be a liquid at room temperature. Remember we talked a while back about vegetable oil versus Crisco, right? Vegetable oil has cis double bonds in it. Because the molecules don't fit together very well, it's a liquid. Versus Crisco, they've hydrogenated that double bond, saturated the fat, and now they're nice long chains that fit together again. Does that make sense? A little bit? So, humans are capable of synthesizing some fatty acids, other ones you do not have enough of, and they're called essential fatty acids, and you need to eat them. Okay? You have to have them in your diet. So saturated fatty acids look like this. They contain all single bonds, and they stack nice and neatly. They're normally solids at room temperature. Think of Crisco. They've hydrogenated the vegetable oil so it's now saturated as opposed to being unsaturated. Okay? So, is this molecule an acid? So here this is oleic acid. Is it an acid? Well, the name says it's an acid. Why is it an acid? It has carboxylic acid head on it, right? You gotta recognize these functional groups, guys. Important.
How do you pronounce it again?
Carboxylic acid. Carboxylic acid. BOX. Okay. How many total carbon atoms are in there? How many total carbon atoms are in that formula? The ones with the 7 on the outside mean you have 7 CH2 groups. Okay? So you have 7 and 7 is 14 plus 4 more. There's 18 carbon atoms.
And you don't count the one maximum?
Yeah.
You did count the one?
Yep. 7 plus 7 is 14. 1, 2, 3, 4 more. That's 18. Is this a saturated, monounsaturated, or polyunsaturated? Why mono?
Because it only has one bubble.
There's one double bond. It's monounsaturated, right? You think it'll be a solid or liquid at room temperature? Probably a liquid because it's unsaturated, right? It's going to be soluble in water?
No.
Look at all them dang carbon atoms. What have we been saying? Things that have 4 or fewer are going to be soluble. That's got 18 carbon atoms. No fats are soluble in water. Okay?
So when you're referring to that chain, when you had to guess if it was a solid or a liquid?
It had a double bond in it.
The double bond is what you look for? to
Yep.
determine?
Probably means it's going to be a liquid at room temperature. Yep. Okay. Prostaglandins are hormone-like substances. And we're not going to skip that one. All right, this is the only thing we want to talk about, prostaglandins. Prostaglandins are essential when you have pain or inflammation. What the prostaglandins do is they enable arachidonic acid to be converted, they are the conversion of arachidonic acid. So you start with arachidonic acid, it folds back on itself, and it makes a prostaglandin molecule. Now, in order to prevent that, you take what are called NSAIDs, non-steroidal anti-inflammatory drugs. So there are no steroids here. You take a non-NSAID. You might know what NSAIDs are, what are common forms of NSAIDs. And it prevents this molecule from making that little ring on the end. These are the most common NSAIDs right here. So these are what you take when you have inflammation or pain, right? You take aspirin, ibuprofen, naproxen. Hopefully you take them in the daily recommended dosage or less. And most of the students in my other section are already in the vet tech class, so they've already learned about NSAIDs in one of their classes. So when I asked them, so why are high dosages of these things not good for you? One of the most common side effects is GI issues. Do what?
Ulcers.
Yeah, stomach ulcers or even esophagus problems. Why?
So I have acids.
Because they're all acids, aren't they? Yeah, so I was taking, on Monday I'm going to try to remember my x-rays to bring them to you so you can see my knees. I have no cartilage in either of my knees, okay? And so I take handfuls of the NSAIDs. The normal daily recommended dosage for naproxen is, I think they give us the maximal dosage, like 400 milligrams a day. I was taking like 800,000 milligrams a day. Normal recommended dosage for ibuprofen, I think, is maximal amount is like 1,600 milligrams a day. I may exceed that some days.
I thought it was 24.
Is it 24 now?
Yeah, because they come in 500.
Well, they come in twos.
Because my doctor has me on 800 milligrams.
So if you get on Motrin, 800 milligrams of ibuprofen a day without a prescription. If you're taking the over counter, it'll. I think if you're taking it over the counter, they tell you not to exceed 1,600 a day. If you're now, if you have a prescription, he may write it for more, and that's why I often take 2,400 a day, or maybe more sometimes. It's not good for your liver either. Yeah. I mean, I was taking some naproxen, it was irritating my throat. I was starting to have esophageal bleeding.
That's
That's good.
Huh? Does sound good? It's not.